Hello, my name is Ulrich Lehner and I present to you in this webinar how we deal with test data while we perform a transition from a host-based approach into a distributed environment. But first, let me introduce my employer and myself. I work for the LVM Insurance or LVM Versicherung in German. Our headquarters is located in Münster in Midwest Germany, and the company got founded back in 1896 as an insurance association by farmers for farmers. Nowadays, we are open to everyone with the constraint that we are acting in the German insurance market solely. With the end of last year, we had more than 3.8 million customers and yearly revenues of 4.2 billion euros. Now, who am I? My name is Ulrich Lehner. I have a master's degree in applied sciences of IT, and I am a certified software architect. I joined the LVM back in 2021 during the Corona lockdown, and originally I was taken on as a software architect for process automation. Means that I should support teams that want to design their business processes in BPMN and run them with Camunda, or which want to design their business processes in domain-driven design. Originally, because in the past few months I was completely busy with the task to find an appropriate replacement for our host-based test data management tool. This task is extremely important to us because we heavily rely on this test data management tool. And in a perfect world, each and every company should do so. Now, not only companies that develop data-concentric software, but even though companies that use data-concentric software. Companies that don't test their software risk their productivity with each new version of a software, because each new version of a software might have tremendous impact on the business processes of a company. Now, as the topic of software testing is a quite huge one, let me first narrow down the context for this webinar. There are different types of software tests. We can have small tests like debugging or unit tests, and we can also have huge tests like integration tests or system tests. For now, let's focus on the latter one, the system tests. System tests can be seen from different perspectives. We have functional tests, end-to-end tests, acceptance tests, stress tests, load tests, performance tests, and so on. All those tests have one thing in common. For them, we need test data. Question now is, how do we get that test data? There we can choose between mainly three different approaches. The first, I think most simple one, is to generate test data by hand. Means, for example, as a developer, I start to type in some data sets into my database before I develop my new feature. But this approach has some drawbacks. It is time consuming, it is error prone, and especially for us developers, it is quite boring because we want to develop our new feature. Because of those reasons, generating test data by hand is only done for specific scenarios. You can think of handcrafted data sets or test data sets like to drive at night with the headlights of a car. The headlights of a car make sure you get the most relevant information for driving, like the course of the road, traffic signs, or raccoons crossing. But the additional information around you stay in the dark. But those additional information are the ones that take your new feature to production readiness. So this approach is not the best idea, especially when to develop new features for production readiness. Now, you can mitigate this drawbacks. True to the motto, a lot helps a lot, and start generating test data sets automatically. This is the second approach, to generate synthetic test data by automation. But this approach also has some drawbacks. At first, we have a low degree of details. Let's take, for example, a family, father, mother, and 2 kids. To generate such a family or dataset for such a family is quite easy. But how about the details? How about the driving history of mom and dad? How about the health history of all the family members? Probably you won't generate that at first hand. Next point is you have a low consistency. If you don't care, there might be the setting that, for example, the mother is 2 years younger than her biological daughter. Next point is you have a low diversification, or probably will have a low diversification. You probably have the standard use cases or standard cases like the family with a mother, father, and 2 kids. But how the more corner-cased approaches, like, for example, a patchwork family with 5 kids. And you will have a high sterility. Means the data will be designed the way you will expect them to be. But how about, for example, let's take the example of postal code here in Germany. 30 years ago, we had a 4-digit postal code system. Now we have a 5-digit postal code system. And probably all your test data you will generate will have a 5-digit postal code. But your system also has to deal with the old 4-digit postal code as well. And all those drawbacks, feel a bit like the guy we see here. The white collar in a auto shop might be possible, but let's face it, it's not really realistic. You can mitigate the drawbacks of this approach a bit when you increase the degree of detail or increase the diversification, but this comes with an exponential effort. So, yes, synthetic test data might help out, but they are not the best way to get to test data. But we have a third approach left. How about if we get our test data from production? There we have a high degree of details, like in production, as we have all the corner cases of our living customers, for example. We have a high consistency. If we remember the daughter that is 2 years older than her biological mother, this won't happen due to biological constraints. We have a high diversification, as the datasets will be that diverse as our customers, for example, are. And we will have a low sterility if we remember back to the postal code system example I dropped before. All this feels like the guy we see here. The dataset have some history. And with that, they are not that sterile. But this approach has a catch. The GDPR, the General Data Protection Regulation. This regulation at least applies for Europe, and the GDPR states that personal information may only be used for the use case they originally got taken on. So the GDPR prohibits to use datasets or production datasets, for example, for testing. But now, this is not the big catch as soon as we use pseudonymization. What do I mean with that? In pseudonymization, we replace the personal information by some generated information. Let's assume we have a customer, Anne Schmidt, born on 29th of February in 1976. That is the original customer, the original dataset assumed. Now, if we replace name and date of birth, for example, the name Anne Schmidt is set to Lisa Schulz and her birthday is set to 15th of April in 1976, we can use that data set for testing. But we have to keep in mind that we cannot only replace one place or one data set, we have to replace all the data sets for a customer, and we have to keep it in line. What do I mean with that? Let's, for example, assume Anne Schmidt has also a bank account, or we have information about her bank account. So we have to replace the bank account as well, at least the name and the IBAN number. And we also have to replace, for example, the location where she lives. Replacing the bank account information might seem an easy task, as well as replacing the name and the date of birth. But for example, replacing the location might be a quite complex task, because we cannot replace the location by any other location. We have to replace the location somewhere near the original location. Why that? Let's assume Anne Schmidt originally lives in Nussloch in Baden-Württemberg, that is to the south in Germany. If we would relocate her to, for example, Schwarzenbeek, that is 600 kilometers to the north near Hamburg, that would have huge implications, for example, on car insurance or estate insurance. Because what do we have in Nussloch, or in the south of Germany? There we have trees, hills, and in the winter we are lucky a lot of snow. Whereas in the north of Germany we have cattle, sheep, and in the winter definitely no snow. This has huge implications, for example, on a car insurance. So we cannot replace the location by any location or any else location. We have to keep it near the original location. That's just a short view on pseudonymization. Let me go on to our system and show you the architecture, as this has some implications on the way we use our test data management tools. Our IT backbone for the agencies is the so-called LAS, the LVM agency system. Right now we have two versions of the LAS up and running. We have the old approach that is, or the old legacy system that is based on a host-based approach with the application server on top. And we right now transform this LAS system into a distributed environment. Let's first have a look onto the LAS2, or the legacy system. There we have, as said, our application server where all the components are running in. Let's spare the details. What is important for now is that the system runs on one central host database. With regard to test data management, yeah, this is a quite easy task. We have several stages. We have our production stage, and now we want to copy our production data down into our test environments while pseudonymizing the personal information. So what we have to do is we have to distribute our data, our production data, onto the several test stages we have, T, F, Q, and D. In order to do so, we just have to copy the production data down into the test host databases. While we copy, we pseudonymize the personal information. For this task, we developed our own test data management tool called VSNR Test. And this is a host application or host tool that worked for now 30 years, but this only works on a host environment. Now, as we transform our system into a distributed environment, the architecture looks as follows. We split our components into so-called self-contained systems. These systems are closed and only communicate by REST or Kafka APIs. And the data itself is kept in several databases. So the dataset is distributed over several databases. If you remember, for example, the example with Lisa Schulz, some data may stay here in the reference data database, while the information about the healthcare insurance stays here in another database. The question now is, how can we get a clean, consistent copy from all those databases from the production stage down into the test stages? And to make things even more funny, we have several DBMS systems under the hood. We still have running our IBM DB2 host database, and we have some databases running on Postgres as well as running on IBM 2 LUW. Now, as I already asked, the question is, how do we get the datasets consistently from our production stage down into our test stages, and with that, from several databases consistently into several databases? And that was the task to solve. In order to solve the task, we started our own project, which I will present to you now. Let's at first have a look onto the goals of that project. The long-term goal was to replace our host-based test data management tool VSNR Test by a new LAS3 compatible solution, so by a solution that can deal with the distributed world or the distributed databases. As a midterm goal, we wanted to run VSNR Test and the new LAS3 compatible solution in parallel. Means the components that still running or that are still running on the host database, that they have to be covered by VSNR Test, while components that already had the chance to migrate to a new database like DB2 LUW or Postgres, that they are covered by the new LAS3 compatible solution. Midterm in this case means at least for the next 8 years. So my mission now was to design a new software architecture for a LAS3 compatible solution. As I didn't know anything about test data management before, I didn't even know the term before, I remembered my software architecture certification, and especially there, one book that I read from Gernot Starke. This is the English version of the book. And there, Gernot Starke showed a path how to get to a new software architecture. And this path I took as a basement for our project. This path looks like the follow. At first, you have to gather information about the new system that has to be designed. Then you have to analyze the requirements that do apply for this new system. Next, you can design the new architecture. Then explain the architecture to management and developers, and at least guide management and developers during the implementation. Gernot Starke strongly focuses on one aspect that helps a lot. That is the ISO 9126, the quality characteristics of software systems. This ISO standard asks some quite relevant questions that otherwise are neglected. So let me just point out this ISO, and if you ever design a new system, stick to this ISO and try to answer this the question asked there. So I took this path and at first gathered the main information, especially about VSNR tests, what it does, what requirements are met with the system, and I at first wrote down those requirements. When I wrote down those requirements, I on a regular basis got told we are the only one with such a test data management system, and this issue only applies to us. I didn't care about much in the beginning, but as soon as I had the feeling that I gathered all the requirements that apply to our VSNR test system, I remembered one quote that Gernot Starke wrote in his book: "Before developing your own solution, you should investigate how other architects solve the problem." So I started a research how other companies might have solved the problem or the issue with dealing with test data, and it felt a bit like breaking out of our bubble. And it turned out that, of course, we are not the only one who deal with test data. And furthermore, there are several solutions on the market for dealing with test data. And because of this, I convinced the management to switch our original plan to design our own software solution to the new plan for a procurement of a test data management software. And with that, we changed our plans away from a known architecture to the plan for a procurement of a test data management software. The plan looked as follows. We gathered information, analyzed requirements. That was already done when I convinced the management. But then we made a switch. We first wanted to do a market research, then do a product comparison, then run a proof of concept in order to see for our own how the solution might work. And if the proof of concept works out, then we want to introduce the new software or new test data management tool. So we at first started with the market research. Therefore, we designed a catalog of questions that we sent to several vendors that were the most promising ones at a first glance. The answers of those question catalogs, we designed in such a sheet with the goal to get to a ranking of software vendors. At first, we sent this catalog to 5 vendors: Informatica, Datprof in the Netherlands, Delphix, Solix, and UBS Heiner. The answers of those 5 vendors turned out that only one of those vendors really fitted our needs. That was UBS Heiner with their XDM system. So according to the plan, we started a proof of concept. And let me show you some details. We started our proof of concept on 18th of May in 2022. And originally, it should end on 29th of July in 2022. And we ran that proof of concept with 3 people: a technical product owner, a software architect, that was me, and a general product owner. The original end got to 23rd of July 2022 because we saw everything we demanded or we asked for, and even more. And we got that much convinced of the system that, we closed the proof of concept 1 week before due date. That was one interesting aspect. Next interesting aspect were the costs. Originally, we planned 65 man days for the proof of concept. In the end, we used 43. Although we managed to show every requirement we had to meet. Even more interesting was the support we demanded by UBS Heiner. Originally, we bought support for 15 man days provided by UBS Heiner, but we only requested not even 2 days. Why that? Because the system was that easy to set up and to use at the beginning that we didn't really need that much help from UBS Heiner. As soon as you can deal with Docker and a shell, you're good to go. Now, the results were the most stunning. Therefore, let me switch into our Confluence. I'll spare you the details, just focus on the row here in the on the column here in the middle and on the colors there. Green means we managed to prove that the XDM can do the requirements. And now let's have a look. You see everything green. There are only 2 points that XDM could not provide out of the box, but that was absolutely fine to us. One aspect was the so-called source classification. That is a specific of estate insurances. And the second one was an access control for special data sets, for example, when it comes down to questions for the healthcare insurances. Those aspects were quite specific aspects of the insurance business, but XDM showed that it is so open with a plugin system that we can manage to design that on our own. So one can say that the proof of concept was a huge success, and therefore we decided to introduce XDM as an appropriate replacement for our VSNR test. The current situation looks now as follows. As said, we are already introducing XDM, so we are at the end of our plan here. XDM is already running since March 2023 in production. The domain agency management is already up and running. Car insurances is the go live is imminent within the next 2 weeks, if I get it right. The domain reference data is already in preparation far before plan. And the domain brokerage is in planning state right now. So one can say that the introduction of XDM generated a huge pull factor, much higher than we originally estimated, as more and more domains want to switch to or from VSNR test to XDM far beyond plan, or far before plan. Next thing is, if you remember, the midterm goal was to run VSNR test and the new solution side by side, at least for the next 8 years, as long as there are domains that did not manage to switch to new database environments yet. During the proof of concept, it turned out that we can replace VSNR tests by XDM, although some of the systems or some of the teams still are running on a host database. So this midterm goal, will be reached far before plan as well. Now, as I said, I convinced our management to switch from an own design, an own solution, to the procurement of a test data management system. Why that? Let's have a look at the aspect make or buy. Therefore, let's at first assume we have, on the one hand, license costs one time of 450,000 euros and maintenance costs per year of 120,000 euros, just as imagined costs. On the other hand, if you design a system by yourself, let's assume we have a developer capacity of 200 man days per year at a cost rate of 650 euros per man day. Makes 130 euros per development year. Now, if we relate those costs, one can say that for the license costs, in turn, we get 3.5 years of development capacity. Sounds like a lot, but keep in mind that this development capacity has to be split up between back-end development, front-end development, and especially quality assurance. But that is just the monetary aspect. There are several other aspects to keep in mind. As I already said, you get at the same costs a lot of more features when you buy a production-ready system than developing it on your own. Next point is that new systems have to get mature over time. It won't run out of the box quite seamlessly. So you will, especially in the beginning, be busy with fixes and so on. Next thing that might apply for most of the companies is that we have just a little know-how in test data management, and especially in designing and developing test data management tools. In addition to that, test data management tools are just a supportive tool for quality assurance. It's not our main business. In our case, our main business are insurances. And the test data management tool is just used in order to, monitor the quality of our IT systems. And the most important aspect is, especially these days, that developers are a scarce resource. And the question is, do you really want to spend a developer resource on a tool that is not your main business? These are just some aspects. If you get to the point make or buy, we chose the way to buy or procure a software system, a test data management tool, and it turned out at least for us, it was a good decision to do so, to buy ready-to-use software. Now, at least let's have a prospect how we want to go on with our test data management tool. The goal we want to achieve with that in the long term is a high degree of test data automation, especially for system tests. Therefore, let's have a look at the infrastructure. It's a mixture of what we already have and what we plan to integrate. We already have Jenkins and nowadays the XDM running. And we are right now introducing a Kubernetes system. Now, what we want to achieve is that we build up our skyline, the LAS3 systems I showed before. Then we get new databases as soon as we start our new skyline. We get clean, empty databases, and those databases now need to be filled with test data. This step is done by XDM, or will be done by XDM. Next step is to execute our system tests like performance tests, integration tests, and so on. And as soon as we are done with that, we want to drop the whole system and begin from a clean green field again with all the tests. And this is a cycle we permanently want to run in order to monitor the quality of the overall system. And in order to achieve this high degree of test automation, XDM is one of the key aspects in order to achieve that. And with that, I will close the webinar for today. Thank you for your attention, and goodbye.